start off by extending a warm welcome to everybody. So a bit about myself. I'm Gharl Breed. I'm a Microsoft Cloud Architect at DVT, where I specialize in DevOps using open source technologies. I'm experienced in delivery automation and cloud technologies, and my main focus is on application delivery. I'll try not to make this a death by PowerPoint session. So please feel free to send feedback or questions via the comments section. And this will be handled at the end of the session. So I think let's dive in. And so today we're going to be discussing DevOps, what it is, where it came from, and how it can benefit you. So we will start off with a brief history, looking at two previous models which you might currently be using for delivering solutions, the waterfall and the agile model. Looking at these two previous models will help us understand what DevOps is, where it came from, and how it differs from the other models and how it leverages best of both waterfall and agile. So we then look at DevSecOps and how it differs from DevOps. And moving on, we look at the community on how to calculate cost savings and provide better understanding on the DevOps return on investment. And then finally, we will go through a couple of key advantages that DevOps brings to you and your teams. So the first process model to be introduced was the waterfall model, and has been the de facto standard for delivering applications for many decades. It is so popular and well known that it is still in use today. The waterfall model is a sequential step-by-step development delivery approach and cascades each deliverable through a series of different stage gates used for building out the solution. So looking at the model, we can see each of the stages required for building out the solution. The waterfall model starts by capturing the requirements, and this is where we meet with the customer to understand their customer-specific requirements, the customer needs and what they're looking for. So stage two, the design stage, is where we build out the project plan from the requirements and understand resources that will be needed to build a successful application. And then during stage three, the development team starts the building of the solution. This is the actual stage where the coding starts. This is the longest stage and can take weeks, months, or even years, depending on the size of the project. And then once the development team marks the solution as finished, the testing team would then take the solution through full regression testing. So testing the application from A to Z. And then after the delivery of the solution to the client, the operation team goes into a maintenance mode. They monitor and make sure the application keeps working. They upgrade hardware or software when required on infrastructure so that they can scale to meet demand. They address security concerns and manage any further support requests that come through. So these steps represent the waterfall model stages, and each need to be complete before continuing on to the next stage. Okay, and so the waterfall model does have some distinct disadvantages. Each cascaded stage runs in a separate silo and operates in a different team. The client is only involved right at the start, giving requirements. So after development starts, the client doesn't have the opportunity to capture any new requirements. So imagine 6 months down the line, the client wants to introduce a structural change. The entire process will have to be restarted. Or in the event, when we deliver the solution after 6 months and the client starts pointing out sections that were implemented incorrectly, you'd have a very, very dissatisfied client. So if something was captured incorrectly in stage one in waterfall, or if the customer requirements change, it could have a huge financial impact. I think this makes the customer scared to introduce change, and ultimately the solution won't match their requirements. So the waterfall model outcomes have been noted as inflexible and not allowing for changing requirements, expensive and very time consuming. So where solutions should be delivered much, much faster. This led to a new model called Agile, introduced in 2000, to focus on quicker delivery. And the main challenge the Agile model is trying to address is the lack of customer involvement. So by involving the customer on a regular basis, you would get a better understanding of the customer requirements and in turn provide quicker delivery. So using Agile model, developers create prototypes and clients provide feedback, so quicker feedback. And with quick customer feedback, the developers can adopt system change in a much faster way. So essentially, there's a continuous loop of interaction between the client and the development team going on, so back and forth communication. So this feedback loop is an ongoing cycle of improvement. The feedback loop integrates an ongoing cycle of planning of work items, doing the actual coding, testing and reviewing of the results. So each usually spanning over a 2-week period, which are called sprints. This time period is not set in stone and may vary depending on the actual company. So the sprints are only intended to deliver smaller work items at regular intervals. So every 2 weeks, the customer can see some value when testing the application. So if a change is required and identified in sprint 2, it can quickly and effectively be implemented during sprint 3. So this provides a solution with flexibility to change and change quicker. All right, and here we see the ceremonies involved in the Agile model and explain the approach that's required. So in the product backlog step, the product owner sets out requirements and documents these, usually in the form of epics, features, user stories, or tasks. So epics are the strategic projects, features more the business requirements, user stories, the functional requirements, and then tasks more the technical requirements from the developers. The sprint planning breaks down the work that the team can take on in a sprint. This may include multiple sprints, and the developers capture further technical information on tasks and size each of these work items. The sprint backlog is where the team identifies the backlog or work items that they can commit to, and ideally, these should be delivered at the end of the sprint. So during the sprint, daily scrums are held, where developers provide updates and resolve any blockers or issues causing delays. This is a great opportunity for the Scrum Masters to check if the sprint is still on track. Scrum stand-up should be quick and take around 15 minutes. So, and any major issues are usually taken offline as to not hold up any of the other developers. So the idea of the daily Scrum is to also promote open communication within the teams. Okay, then after the sprint, the development team showcases the changes and provide the client the opportunity to review the changes and provide some feedback, valuable feedback. So the goal at the end of the 2 weeks is to put a running version with the changes in front of the client, and they can review this. So because the client now forms part of the loop in the Agile model, the client requirements are better understood, and the developers can quickly and effectively develop precisely what the client requires. So value is delivered much faster compared to the waterfall model. Okay, and then, so there are, however, some distinct disadvantages with Agile 2. The solution is not really tested in a production environment. So this usually happens on the developer's machine or in a QA environment. The developers and the operations teams are not synced, and they still kind of work in silos. So if you think back of the waterfall model, the different stages and the different teams, this is kind of where Agile also has got a disadvantage. So when a client is happy with the development and the developers are done with the solution, they kind of pass the solution over the wall to the operations team with little to no clear instructions on the technical requirements. So the operation team is responsible for making sure the solution runs stable in the production environment. But this is very difficult to do when the teams are separated. The developers can have, the developer could have used a different operating system, different frameworks. There might be missing dependencies or different setup not running in production. So Agile brings the customer closer to the project, but the disadvantage is the ops teams are still separated. and they work in a separate silo. So this should look familiar to everybody. The famous, yeah, but it worked on my machine. So this is where this comes in. So this is where DevOps comes in. So as the name takes, dev from development and ops from operations, DevOps is the evolution of the agile model and provides a process where developers and the operation team can work closer together. So DevOps leverages and borrows the best of waterfall and agile. So DevOps is still very, very closely related to agile. Same ceremonies, everything. It just brings the operation teams closer. So in short, DevOps is basically agile development with agile operations. Okay, agile model addresses the challenges and gaps between the client and the developer by providing the feedback loop. Where DevOps, the DevOps model looks at addressing the challenges and gaps between the developers and the operation teams. So DevOps is not a tool, it's not a software or programming language. You know, DevOps it's a philosophy or strategy intended to deliver increased business value and responsiveness through quick, high-quality service delivery. Okay, so it's the key for successful quick delivery. Getting something in a production environment quicker. Okay, moving on. So here we see the phases or the stages of DevOps. And this is a combination of planning, coding, building, you know, testing, continuous releasing and deployment, operations and monitoring. So it's still very similar stages to Agile. It's just an infinite loop, and the infinite loop symbolizes ongoing continuous integration, code and, you know, feature upgrades, and a continuous delivery, you know, value delivery models. So this is known as your CI/CD pipeline. So let's take a look at this in a bit more detail. Okay. So as it evolved from Agile, a lot of the same steps are used. The plan phase, as with Waterfall and Agile, this is where we understand the goals of the business. Then the actual development happens in the coding stage. We build the build automated pipeline builds out the packages in the build phase. And then as DevOps puts a lot of focus on automation, so should the testing also be automated. So scripted tests are introduced to automate testing, and this also happens in the same pipeline as the build phase. So automated testing is actually integrated into the pipelines. And then we look at the release of the integration phase, merging new features to the release branches, so setting up the packages. And then we look at the actual deployment. So the deploying the releases to a QA or production environment. So I say QA or production as there could be one pipeline for each of these environments. And then the operation teams use configuration tools to get the desired state of the environment through automation. An example of this would be like a CloudFormation environment where the entire cloud infrastructure or environment is scripted and can be spun up with a click of a button. This is also introduced in the actual code. So as you release, you can spin up the full production environment. Okay, and then lastly, while monitoring, we measure how the application performs in the real world. So I read an awesome quote, you can only improve what you can measure. So we don't just want to monitor the application. The monitoring solution should ideally have an holistic view of the application running, checking infrastructure that's hosting it, getting notified when hardware failure occurs, software bugs, and you should even be able to debug long-running queries. So in the DevOps world, the key focus is still to speed up delivery. Where waterfall delivery is weeks, months, or even years, depending on the solution size. Agile is usually a 2 week, 2 months based on your release cadence. And then DevOps ultimately focusing on multiple releases in a single day. Okay, so there are many leading companies getting this benefit by embracing the DevOps teams as part of their solution delivery structure. Some of you might be thinking, we're already doing DevOps, so where to from here? And others might be wondering, are we using Agile or are we doing waterfall? And be thinking, how do we achieve a transformation to the DevOps culture? Okay, so then we've got the two groups. So on the left, those not yet utilizing DevOps might be wondering, okay, how do we get started? So what should our first steps be? And I think you've already taken the first step in understanding DevOps. So the next steps would include investigating your current environment, identifying areas for improvement, building out a test pipeline to get used to the environment, investigating automation tools, containers and monitoring. And some of the processes that you're currently using might just work in this environment. So it might not be such a big change. The tools are really an interesting topic and would fill a presentation on its own. So, and developers I know get really excited when looking at the different tools, trying to automate and build out the CI/CD pipelines. But we'll leave this for a later discussion. Okay, and then I would also like you to encourage to reach out. I think partnering with a certified partner is probably the quickest way to get started with the DevOps culture. Okay, and then next, for those of you already doing it on the right, and looking for ways to improve, Google did a study on DevOps, the State of DevOps report, and found a significant return on investment for companies improving their pipelines. We'll cover the state of the DevOps report a bit later. So just know that it's a good place to get recommendations for companies seeking to evolve their DevOps practices. And other options might include scripting out of your infrastructure. So infrastructure as code, that might be a next step. Looking at ways to improve your deployment strategy, have quicker deployments, monitoring of each phases, making sure everything is in place. And then lastly, looking at DevSecOps. Okay, so as the name suggests, so as we said with DevOps, dev from developers, op from operations, we're including the security section in the middle. So it actually forms part of it. So DevOps addresses the challenges and gaps between the developers and the operation teams, where DevSecOps addresses the challenges and gaps between the developers, the operations, and the security teams. So baking security into your solution is fundamental. So instead of having a siloed security approach, each step should automate the relevant security checks. Previously, security was handled by a separate team. With DevSecOps, the security teams work hand in hand with the development and the operations teams. They will provide advice, recommendation on best practices, and even help select the security tools to be used within each stage. So they'll assist in designing the security plan and tools throughout each of the stages. The security team usually uses penetration testing companies or might be tools for automation within their pipelines. This will actually form part of the monitoring phase as well. So any vulnerabilities that get logged again through the pipeline would actually then form part of the actual CI/CD process. If a vulnerability is identified, it goes through the same step as a code change. If a plugin needs to update, same story. So DevSecOps puts a lot of focus on adding security checks into each stage of the DevSecOps process. And in turn, this approach then shares the security responsibility to all members of the team. So it's not a specific team that's on the one side in the silo. It's actually everybody is involved with the security upgrades and the security testing and the security monitoring. So the primary goal is actually to minimize the attacks and defend against cybersecurity hacks. So on the right, you'll see some benefits of DevSecOps and using DevSecOps. So automated security tools that do the checks on your behalf, faster release cycles. So when a security vulnerability is detected, it is then and there resolved. And like a developer change, like I said, when security risks are found, it is addressed immediately like a system upgrade. So overall, you'll have a more secure environment. and also complying with industry standard regulations. So let's put a smile on an auditor's face. Okay, let's move on. Okay, so now that we understand the phases of DevOps, we're going to look at the return on investment when moving over to a DevOps culture. So in this section, we will see how the community came together to measure the impact of DevOps through the state of the DevOps report. And that's what it's called. So it's the state of the DevOps report. It just changes year on year on year. So it's been an ongoing report tracking the impact of DevOps over thousands of companies from all over the world and more than 40,000 technical professionals participating. So it's a data-driven insights report aimed at software delivery and operational performance. And it is the longest running and most widely referenced DevOps research in the industry. So before we take a look at some of the insights of the report, I would just like to note, let's go here. So in 2019, a global survey was done and features DevOps among the top impacting technology trends at a global level, in comparison with other trending technologies or solutions. So DevOps was rated as the second most impacting technology trend in 2019, after edge computing or IoT. So artificial intelligence or machine learning, containers, blockchain, and virtual reality were only next to DevOps in 2019. So pretty amazing. So what made DevOps so special? And the answer lies in the impact on the organizational performance that you get from it. So now let's have a look at the insights of the state of the DevOps report. Okay, so the state of the DevOps report is freely available online. You can download the latest 2021 version at cloud.google.com/DevOps. As of 2019, the state of the DevOps report reported that IT organizations embracing the DevOps journey see 100 times faster lead time from commit to deploy, 22% minimized time from unplanned work and rework, over 2,000 times faster recovery from failures, 208 times more deployment frequency, 2 times more employee satisfaction. So quicker delivery keeps the environment clean and there's less buildup of planned deployment items later on. So, and then 18% improvement in customer satisfaction, 6 times more accuracy in estimating operational costs, and 7 times lower failure rates. So failures are even easier to track as the deployments are smaller and easier testable. So, and I know these results are mainly value driven. It's more difficult to calculate an exact financial saving when moving to the DevOps culture, as it impacts so many layers. But Google did do a white paper on it, and they defined a formula for the calculation. The white paper also uses key metrics from the state of the DevOps report in order to estimate the potential return on investment. So moving on. So the two numbers, there are 2 numbers that should be considered when calculating the return on investment. This is the actual investment costs, like your resources, your technology, and your training that you need to invest with when moving over, and then also the return. And the white paper focuses mainly on the calculating of the return aspect of the ROI, so the return of investment. The investment will depend on the organization and where they are on their current journey. So when you do that calculation, remember to include your cost beyond just migrating to DevOps in your investment calculations, like your loss in productivity from learning the new environments, integrating new technologies or way of working, and at any time spent on re-architecting or replacing existing systems. So when calculating the return, organizations have 2 carriers of costs that and resources that they should always consider. And these are first value-driven, and the second is cost-driven. So value-driven return categories include, quick responding to customer demands, optimizing for speed over cost, value lost from postponing new products, and could have actually made revenue if released more quickly. So basically, in other words, what's your cost of delay? And then cost-driven categories, focusing on savings and efficiencies we're implementing or moving over to DevOps. So looking at automation, and then cost of downtime and cost of rework. So, and also keeping in mind that all costs that a business avoids are considered returns to the business, forms part of this. Okay, so let's see how the return on investment calculation breaks down in terms of both value and savings. Oh, and there's a link at the bottom there, guys. So the white paper is also freely available on the internet. You can just go Google the white paper, and the link is there as well if you want to follow that. Okay. So Google measures your potential return as a combination of the value of your reworked recovered and the value of the lost from new features plus the cost of downtime. Calculation there. Okay, and let's see how to calculate each of these. So we'll dive in a bit more detail. So calculating the cost from avoiding unnecessary rework using the follow equation. So you multiply the development team size with the salaries paid, the current benefits of your employees, so the leave, pension, medical, and so on, and the percentage of non-value added work. This will give you an idea of what you are paying for development on only reworked items. Okay, moving on. The formula they use to calculate the potential value added from reinvestment from the previous gains. So reinvesting, saving that time and reinvesting that time into revenue generating features. So the time wasted on rework could have provided gains elsewhere. So revenue generating features are broken down into running experiments. So in the section here at the bottom, so running experiments, so testing features on customers, new processes, new layouts, for example. So quick deployments assist in actually calculating the impacts of these on customers. So if there were negative feedback, then it could be quickly addressed, it could be rolled back, new deployments can go up because you're deploying at such a frequent rate that you can test it properly. So, I mean, how many of us were upset with the Windows 8 release back in the day, and it took Microsoft 3 years to release Windows 10? So I know we don't have a show of hands, but I think it was probably a lot of you. Like, I was pretty frustrated, and I didn't ever think of purchasing a computer with Windows 8 on it. We had to actually wait 3 years before we got a new release. So then moving on to the line of business. So this could be seen at each service or software you currently provide. The idea success rate. Okay, of course, not every test yields a return, but it's still time better spent than doing rework, and the same with idea impact. And then lastly, the product business size. So then for many organizations, the revenue potential of new features is the function of the current revenue of the product or business. Okay, then we move on to cost of the downtime. Okay, so looking at the formula for costing downtime per year. So you multiply your deployment frequency, your failure rate per deployment, your time to restore a failure, and all costs incurred while the application is down. And this should actually be visible, immediately visible with your current deployment processes that you've got. Okay, and then finally, we can put it all together. So your potential return would combine the value of your reworked items, which you've recovered, plus the value of lost or new features that you could have provided, and then plus the cost of your downtime. So the yearly returns are much larger than most people estimate. So now also consider the additional gains not included in the calculations, like improved employee morale. So employees working on newer technologies, working on value-added work instead of non-value-added work items. And also longer retaining of customers. Happy customers will stay with you longer. Okay, and then moving on, some quick ways to check if you could potentially save is to look at how long does it take does it take to get your application into a production environment, the total number of downtimes that you might have, the current team's velocity to 1 during a development sprint, so you can do a test and go through it, and then the total counting the total failed deployments. These are all key metrics and can even be measured or included in a KPI. So let's recap some of the advantages DevOps brings to you and your teams. So DevOps, ultimately the promise of faster delivery, and this provides quicker time to market, flexibility to change quicker, internal technology improvements, and more business automation with some less complexity. Because everything is a bit automated and scripted, it'll be less complex. And of course, lastly, overall happier customers. I think that's the goal we're all aiming for. And then to summarize, so in summary, we looked at the waterfall, where solutions take longer time to market. Then we looked at agile, which evolved from the waterfall to increase delivery time and bring the customer closer to the project. And then we moved on, we looked at DevOps. So leveraging best of both worlds for speedy delivery and to production, and bringing the customer closer as well. And DevOps brings the operation team closer to the project. We spoke about scripting out of the environments and automating the pipelines. And then we looked at DevSecOps, which integrates security into the delivery approach or the delivery process and shares security to all members of the team. So everybody's involved with that. And then lastly, we went through the ROI, the return on investment, and the calculations of how to calculate these. And yeah, we also saw how Google focused on value and cost to build a calculation model for costing. And then also downstream benefits that might not be immediately visible, like retaining your customers for longer, quicker delivery, and ultimately more stable environments. Okay. So that brings me to the end. I'd like to thank everybody for joining. I thought this was a great opportunity to showcase the different models and how DevOps can be a huge benefit for you and your teams. So, and if you would like more information, just visit our website or feel free to reach out to us. And I think, Karen, that's it on my side. I think we can head over to the comments section.
Yeah, wow, well done, Gharl. I think
I said quick and no death by PowerPoint presentation. So there we go.
That was an awesome summary of DevOps. I think if anyone didn't understand DevOps from a higher level, they certainly got to understand it today. So thank you. That was really, really worthwhile and fascinating to listen to. I think.
Excellent.
Thank you. I think just from a questions point of view, if anyone has any questions to ask Gharl, you're welcome to pop it in the chat section. I see we had a comment from Ilse earlier on. It was when you were busy showing some of your earlier slides. And she just mentioned that she said, my assumption is that the operational SME is part of the core team and is involved from the start. So
that's correct.
That's
so so when building out the operation or the solution, the operations team need to be involved with where they're going to host it, what's going to be the environments, where does it, what does it actually look like in your actual desired state, your final environment, what's going to be, and they need to be involved to know what type of RAM is going to be used, what type of CPU is requested. Is it an agnostic approach to deploy to only one maybe environment, or can you have a lift and shift environment to different cloud platform providers? So definitely your assumption is correct. Okay.
Right. Are there any questions that anyone wants to pose on the chat? You can pop them in now if you'd like to. If there are no questions, it seems Gharl gave a very good explanation of DevOps this morning. Yeah, something interesting to note, and if you follow our DVT LinkedIn page, there's an interesting post today that was shared regarding how people in space and astronomers and NASA, how they're using DevOps in space. And that's something worthwhile having a look at. I'll actually pop the link in the chat just now, but it talks about how DevOps is transforming how they're taking edge computing and continuous updates to space. So it just goes to show that, DevOps is used in corporate businesses as well as in space. It's definitely the way to go. So let me just pop that.
That's very interesting, because that's the thing about DevOps. It's not, like we said, it's not a tool or software. It's actually a philosophy to just deliver something quicker. And that's what the core is about. And I think DevOps is actually also, or agile, let's say the agile methodology is also a bit evolved into like the scaled environment, scaled agile environment.
Exactly.
Where this is not something that's going to stand still. This is something that's going to be with the IT infrastructure and the environments. It will evolve with time. As you saw, we've had the waterfall, the agile, the DevOps, the DevSecOps. It's a continuous evolving environment in order to provide faster delivery, quicker and more stable environments.
Absolutely. And something to note is software is getting smarter, better, and easier to update. But the amount of computer power needed to execute the software commands in space are growing exponentially. So, DevOps just gives it that functionality and that strategy to move it forward. So yeah, it's a fascinating topic. It really is. Are there any questions? Okay, so there's somebody saying, will there be a recording? Yes, definitely. I will share the recording with all of you who've been on this call today, and I'll pop you an email with a link to the recording on our YouTube channel. It's Gharl, there literally are no questions. Unfortunately, that was a really, really good session. So I think if there's anything else, not anything else from your side and anything else from the audience, I think we're going to call it a day. And I'll get the recording to everybody. And I just wanted to say thank you, Gharl, once again for your time and your expertise. And
thanks for the opportunity.
Yeah, thank you. And we will still be having another DVT Insights session towards the end of November on robotic process automation. That's our next session on RPA. So keep a lookout on our social media channels. You'll definitely get to see where to register for that. But yeah, in the meantime, I want to say thank you to all of you for taking part and listening to Gharl and myself today. And we look forward to seeing you at our next session. So yeah.
And if anybody's interested, just pop us a message if you are keen on seeing a tools presentation and what type of tools, open source technologies are available in order to speed up your delivery process within your CI/CD pipelines. So let us know. Thank you.
Awesome. All right. Thanks, everyone. Go and have a wonderful day.